Okay, having known the formulas for solving this, in our next contact, we are going to be looking at calculations, isn't it? Going to find calculations. So when you go home now, what are you going to do? You're going to find questions under what solubility, their calculations, and what start solving. Even theoretical aspect of it, has questions, isn't it? Now, we're looking at solubility now, right? We've done solution, and it was a nice, an interesting one, isn't it? Well, an interesting one, isn't it? Good. So, let's look at solubility as another subtopic under solution and solubility, right? Now, we already stated that solubility is the ability of solute to be dissolved in solvent, isn't it? Now, I want us to look at it from chemistry aspects. In chemistry, okay, the essence of solubility is for saturation. The reason you're taking your cube of sugar into water is because you want to saturate that water. Am I communicating?
That's true.
So, for us to calculate the solubility of a substance, okay, the sugar, let's take it as a salt, okay. Now, the reason for us to be able to calculate the solubility of that sugar in the water, we have to make the volume of water a standard. Am I communicating? That's why you have a standard solution, isn't it? So when you have standard solution, we are talking about a solution that its concentration is known. So the concentration of the concentration of a solution, once is known, you took the HCl solute, you pour it in water, you dissolved it, right? So you form what? Hydrochloric acid, for instance. Automatically, you attend to, if your experiment or your practical is standard, you have to do it with standard physical values. And what is standard physical values? You have to make sure that whatever solute you are dissolving, whether in mole or in mass, like whether in amount, which can be in mole or in gram, isn't it? So you have to know, you have to measure it out, like you have to measure the mass, okay, whether in mole or in gram. That's the first thing you need to do. Then two is that the volume of water, we're using water, which because water is a universal solvent, right? So we're using water as a standard, right? So the volume of that solvent should be 1000 cm cube, or what? 1
dm cube,
or what? 1 liter, isn't it?
Yeah,
it's very important. That's why whenever we are preparing practical solutions for titration during WAEC, okay, we have to make sure that our volume of acid which we are preparing, am I communicating?
Yeah.
Must be prepared with what? With 1000 was cm cube or 1 dm cube of water. If not, that experiment is not a standard one. Am I communicating?
Yeah.
Am I communicating? So what's solubility in chemistry? This is said to be the amount of solute which is able, the amount of solute, okay, the amount of solute in bracket in mole or in gram, close the bracket, which is able to saturate the amount of of solute in mole or in gram that is able to saturate 1000 cm cube, 1000 cm cube or 1 dm cube of water. Am I communicating? Now, I didn't ask something. Do you know that if you should take this this definition to the bank and use it like that, you might get it wrong. Am I communicating? Let me tell you how you're going to get it wrong. If you're performing a practical, you're trying to form a solution, a standard solution, right? And you are not conscious of the temperature of the environment. You're not conscious of the temperature of the system. You might get it wrong, because if you have an increased temperature, are you getting my point? you tend to have a blunder in the calculation. Don't forget, when temperature increases, volume will increase simultaneously. Am I communicating? Yeah. So whenever you are doing that experiment, you have to do it what? At a particular temperature. So if I want to define solubility, I have to say that solubility of a solute at a temperature, am I communicating, is said to be the what? The amount of solute in mole or in gram able to saturate 1000 cm cube or 1 what dm cube of what? Of solvent in that temperature. Am I communicating? Are we together? Are we together? So with this, we are going to be looking at factors affecting solubility before we start moving into the the calculatory part of what? Of solubility. Are you there? So number one factor,
temperature of moisture.
Number one factor, of course, these two, I think it's too bogus. Okay, it's bogus already. What I'm going to do, I will just have to explain it. Okay, so that you will not keep on writing. So once I'm going to explain it, you're able to write down something depending on how you understand it. So number one, the condition of the environment or the system will affect what solubility. The condition. Just like I told you, what will happen when you have increase in temperature? The solubility increases. When you have increase in temperature, solubility what? Increases. Why? Who can tell me why? When you say that solubility is the ability to do something, isn't it? So if a substance is being dissolved when the temperature is high, the particles of the substance, both the one that is being dissolved and that of the one that's the dissolver itself, right, will tend to acquire what? Enough kinetic energy. Am I communicating? So their dissolution will be faster. Am I communicating? Mm-hmm. Good. So the vice versa will happen on what? Decrease in temperature, right? Isn't it? Good. Where the solubility will generally what? Decrease. Due to what? Decrease in temperature. Because in decreasing temperature, you find that the particles of the what? Of the substance tends to come together. They will not be able to be moving and vibrating as fast as possible. Am I communicating? Mm-hmm. Good. So let's go to of course, pressure will also affect it, isn't it? Pressure. So what happens to increase in pressure?
It will decrease solubility.
Huh?
It will decrease solubility.
Anyway, it depends, right? Isn't it? If it's solid, it will have no skin counter effect. Pressure only affects what? Gases. True or false?
True.
Do you understand my point? Whenever you're looking at pressure, you find out that pressure only affects what? Gases. So both decrease in pressure and increase in pressure for solid will not be affected. Am I communicating? So let me look at the next factor, which is so the first one I did was solubility of solids. Okay, so for solid, pressure will not affect it. Do you understand my point? Do you understand my point? Right? Then for liquid now, increase in pressure, of course, that is meant to be increased. Of course, sometimes it will vary. Let me show you how it varies. I think you should write this one down. For solubility of liquids, right? I said increase in pressure will vary. The effect will vary, right? Now write it down. Write it down. So this depends on the liquid interaction. It depends on the liquid interaction. So if the two liquids are miscible, what will happen? The dissolution, the solubility will increase. But not every liquids are miscible, right? Yeah. There are two liquids that when we bring them together, they are immiscible. Oil and water, they are immiscible. Am I communicating? Yeah. Even though you are increasing temperature, what do you think? Am I communicating? It will not, of course, it might just, in a way,
to an extent,
slightly or sparingly what, dissolve. Yeah. Water will dissolve in it, in oil, in a higher temperature. Leave it after cooking. Leave it now. You see the water. You see the oil floating again. Am I communicating? That's why for increase in temperature for liquids, am I communicating? Is going to be having what? Variable effect. But for solids, straight up, generally, once you have increase in temperature, it will affect what? Solid or solubility. Am I communicating? Generally. So what about decrease? Of course, the same thing, depending on the what? On the miscibility of what? Of the liquid. Am I communicating? Because we're looking at liquid dissolving in liquid now. Initially, we're looking at solid dissolving in what? In liquid. Am I communicating?
Yeah.
Do you get the point? What about pressure? Of course, since both of them, or since we're not talking about gas, no significant what? Effect. Are you with me?
Yeah.
Are you with me?
Of course. Sir.
Since we're not talking about what? Gases, no significant what? Effect. Now, look at this one. Solubility of what? Of gases. Look at the effect of the increase in the physical conditions. Now, what do you think will happen to increase in temperature for for gases? Automatically, it will obey kinetic theory, isn't it? It will increase because the pressure will increase. Are you getting my point? So, for increase in temperature, okay, for increase in temperature, like I said, it will do what?
Increase the solubility.
It will increase solubility. But when you consider a gas being dissolved in water, am I communicating? When you normally once you have increase in pressure or temperature for gases, right? The gases tends to become more energetic because they will absorb kinetic energy, which is energy to what? To move. Or to break what? At rest, to break being at rest, isn't it? And they begin to move. So if they begin to move automatically, if the condition, which is the dissolver, is not affected, is still okay, right? Automatically solubility will increase. But what happens to solubility of gas that you are trying to dissolve in liquid? Will it increase or decrease? It will decrease. It will do what?
Decrease.
It will decrease. Do you know why? Who can tell me why? Let's not waste our time. Now, right. The solubility will decrease for gases dissolved in water, right? It will decrease, okay, for most gases in liquids, right? Solubility will do what? Will decrease for most gases when dissolving in water, right? It's very simple. It's because at higher temperature, I get to my point, most gases tends to escape faster. You want to dissolve it in water, but you're increasing temperature, the gas will leave. Do you get the point now? So it's not dissolving, except that of what? HCl. Very important point, right? Except that of what? HCl. Okay. So what about decrease in temperature? The reverse will become the case. So solubility will do what? Will increase. Are we together? I mean in water, right? So let's look at increase in pressure. You know now what will happen? Okay, let me just go straight. Of course, pressure will affect gas, positively when it comes to energy buildup. Am I communicating?
Yeah.
But when you are now dissolving gas in the liquid, do you still think that it's going to affect your aim, which is to dissolve the gas in the liquid? What will happen? What will happen? Increase in pressure, what will happen? What happened in the increase in the, what do you call it? Temperature will also what? Happen, right? Isn't it? Sorry, the reverse case of what happened in increase in what? In the temperature will happen when you are what? Mounting what? Pressure. Am I? Now, when we did Boyle's law, we actually what do you call it? Explain that, right? When you are mounting pressure on the particles, it becomes more compressed. And as it becomes more compressed, what do you think will happen? It will be coming together, it will be going inside the dissolver. thereby increasing the what? The solubility. Am I communicating?
Yeah.
Are you getting my point? So when you're mounting pressure in what? In a gas, as you want it to get dissolved, as to dissolving it in water, in liquid, for instance, the pressure will cause the gas, interwater force to become what? To become not negligible again. Am I communicating? It will become significant to what? Effect. So they will come together, then get what? Compressed. Are you getting my point?
Yeah.
Then they will be able to what? Mix what? Faster. That will be what? Increase in what? Solubility. Are you with me? Are you with me?
Yeah.
Okay, so this increases as gases are compressed and forced into liquids. Do you see that? So increase in pressure means what? Forcing the particles of what? Of gas to become what? Compressed. But what happens to the volume? The volume will do what?
Decrease.
Will decrease. If you're increasing the pressure on a gas, the volume of the gas will be decreasing simultaneously. True or false? Solubility decreases as the pressure is reduced, allowing gases to escape. Do you see that? So what happens when you're increasing temperature will happen when you're decreasing what? Pressure. True or false? Because they're not more mounting compression force there. They can leave from the water, from the liquid, thereby not causing the what? The solution to become soluble, or the solubility to occur. Are you with me? Now, these are important parts of this. For those of us that are getting tired, I think that is your case. Okay, that is your what? Your case. It's not our business. Let's look at general solubility rule. These are the important parts of this word topic. Am I communicating? Now, here you need to learn it. When you learn it, you need to assimilate it. When you assimilate it, you need to push it down to your bloodstream. Okay? From your bloodstream, let it enter into your what? Bone marrow. Without it, you might be asked with some questions, even both on calculations and on what theory. You will not be able to answer anything. That does not mean that you don't know solubility, but you don't know how this salt, reacts. How this, so whether this salt is soluble or not. So this 7-8 rule, as case may be, that of course there are many of them, but I just compressed it. Okay, so this was now, if you know it, you'll be able to know the remaining. Are you with me? Number one rule is that most chloride salts are dissolvable. Most chloride salts are soluble. Name is what? Soluble, right? Are soluble, except lead chloride. Yeah, except what? Lead chloride.
PbCl.
Yeah, PdCl2, right? Mercury chloride.
AgCl2.
And silver chloride. Now you can even rephrase what you just said. You can say that all chloride salts are soluble except these chloride salts: lead chloride, mercury chloride, and what? And what? Silver
chloride.
If you like, you write it. If you like, have it off hand. If you like, just play with it. All I know is that what? You are going to see it in the exam. Are you with me?
Yeah.
Number 2, right?
Yeah.
Salts of sodium, potassium, and ammonium. Salt of what?
Sodium.
So sodium plus,
potassium
plus, and what?
And
NH4 plus are soluble. All of them. So which means sodium hydroxide should be soluble. Sodium chloride should be soluble. That's why your table salt is soluble, right?
Yeah.
Potassium hydroxide is soluble. Of course, it's a base, but it's soluble because of what is potassium, right?
Yeah.
Ammonium chloride, soluble. Am I communicating? As far as it's not an exception of what this, which means when I have NH4Cl, for instance, this guy should be soluble because of what? NH4. Am I communicating? Just imagine. Are you there? Are you there? Number 3. Make sure that you do not enter this class again. Let's just stand there. Number 3, right?
Yeah.
Number 3, most sulfate salts. Most sulfate salts. You are not writing. Again, in every class, you will not be writing. You want to copy from another person. Most sulfate salts are soluble except barium sulfate, lead sulfate, except barium sulfate. Barium. See how they are doing face as though they not hear about barium. Barium was sulfate, lead was sulfate, and the what? Calcium sulfate. So barium sulfate, lead sulfate, barium sulfate, and the calcium sulfate. All these guys are not what? Cannot be dissolved in water. They are not soluble because they are what? Salts of sulfate, right? But calcium, do you see it? Lead and barium, am I communicating? Cannot be able to dissolve in what? In water. But think about it. Sulfuric acid, H2SO4, soluble. Am I communicating? Calcium, potassium sulfate, sodium sulfate, all of them can what? Can dissolve. Even think about it. When you say sodium sulfate, potassium sulfate, all sorts of sodium and potassium are already soluble. Am I communicating? All sorts of sodium and potassium are already soluble. So whether you even put sulfate or not our business, right? So that is the rules or laws you have to what? Take. If not, questions under qualitative analysis would not be what? Under solubility will be hard for you. And somehow under qualitative analysis will also be hard for you. Number 4, almost all nitrate salts are soluble. Almost all nitrate salts are what? Soluble. That's NO3, right? All of them. So think about it. HNO3, okay? Sodium nitrate. Think about any nitrate.
Potassium nitrate.
Potassium nitrate. Any nitrate at all. All of them are what? Soluble.
Soluble.
Are you with me? Number 5 or number 4?
Number 5.
Most hydroxide compounds, right? Most hydroxide compounds are partially or called sparingly soluble. That should be an exception. Think about it. Which exception? Tell me who is bright here and who is.
Except sodium and potassium.
Except that of what? Sodium, potassium. Am I communicating?
Yeah.
Am I communicating?
Sparingly.
Good. Some parents are too busy in their brain doing nothing, getting confused and confusing their generation. That's by the way, right? Isn't it? Good. Now we've already said that what? All sorts of sodium and potassium are what? Soluble. But here we say that what? That compounds of hydroxides, am I communicating, are partially soluble. Am I communicating? And I say the exception because potassium hydroxide is a compound of hydroxide. So there should be an exception because we already said that what? All compounds of potassium will be what? Will be soluble. Am I communicating? And some persons are what? Are getting confused. Okay? So let me give you the last one. Most sulfides, phosphates, and carbonates are insoluble. Now think about it. Most sulfides. What else?
Phosphates
and carbonates are what? Insoluble. Give me examples of carbonates. Sodium carbonate, potassium carbonate. I get to my point. Now, sodium carbonate will not be what? Insoluble because of potassium. Isn't it? Because all sorts of potassium and sodium are what? Soluble. So even though that's what? That most carbonates would be what? Insoluble. That of potassium and what? Sodium will not be what? insoluble. It will be soluble. Am I communicating? And that is the rule for you. And that is the what? The rules for you. You're also looking at what is it called? Formulas or calculations under solubility, right? Because you've already understood the meaning of solubility and what it's all about, right?
Yes, sir.
From what you understood, the first formula you have to have in your mind is that what? If the solubility in chemistry means the amount of solute, whether in mole or in gram, right, dissolved in a standard volume of water, isn't it? It means that solubility is equal to number of moles, right?
Yeah.
Divided by what? Volume.
Volume.
Are you there? So, when you're being given with they gave you the number of moles of the what or the substance that is being dissolved, right? And that's what is going to be saturated, for instance, or tends to get saturated. The solubility of that substance is what? The number of moles of what? Solute, isn't it? All about what?
Volume.
Of what?
The solvent.
The solvent, right? But based on standard, right? We are going to be using that solubility is equal to what? The number of moles over what? Volume times what? 1000 cm3. Am I communicating?
Yeah.
Or we can use, that is when if our volume is given to us in cm3, right?
Yeah.
So, or we can use the same thing here where we have that what? N all over V times what?
1
dm cube. If the volume is given to us in dm cube. That's why this guy stood like this. Am I communicating? Are you with me? Then this one is staying like this, right? Now, but we can still calculate the solubility based on molar
Volume.
concentration, right? That is a mole per dm cube, isn't it? So don't cramming it from your relation and interaction. You know whether you get it right, isn't it? So for stability based on what molar concentration, we have that what molarity or molar conc is equal to what? You can tell me. Mass concentration. Okay. I think we'd have done the direct. Okay. Is equals to mass concentration. Of course, this is correct.
Wow.
Mass conc,
Over molar volume.
which is in gram per dm cube. True or false?
Yeah.
All about what? Molar concentration. What? Molar mass, which is in what? Gram per mole, isn't it?
Yeah.
So if this is the case, you have that what? You have gram per dm cube divided by what? Gram per what? Mole, isn't it? So you're going to have that what? Gram per dm cube times what? Mole per what? Gram. So this guy will cancel this guy. So our answer will be in what?
Mole per dm cube.
Per dm cube, isn't it?
Yeah.
So this same molarity or molar concentration, which other way can we do that? Molar conc is equal to which other way? Okay, let's check the mass of the solutes. Are you with me? Or the solutes all over molar mass of the solutes. Are you with me? Are you with me?
Yeah.
Times volume, of course, times 1000 if the volume is in what? cm cube.
Cm cube.
I don't know whether it's correct. Let's check. Is it correct? Is it correct? Are you sure? How is it correct? So when you look at this, you find out that what? You remember, I said, is it correct? Who can tell me? Remember that amount in mole, isn't it? Is equals to what?
Reacting mass.
Yes,
Mass.
reacting mass over what?
Molar mass.
Molar mass. Isn't it? So anywhere I see mass or molar mass, I can put what? My number of what? Moles.
Moles.
Am I communicating? Are you getting my point? Good. Then I'm going to have that molarity is equal to N times what?
V.
Sorry,
N
divided by
V.
what? V. Are you getting my point? Of course, this guy will be per dm cube, like, isn't it? Except if not, I'll put times 1,000. Are you with me?
Yeah.
Are you with me? So if that is the case, this guy, the molar concentration, which is still with same thing with molarity, right? Is what this guy measured in what? Mole. This volume was measured in what? dm3. So my answer is still in what? Mole.
Mole per dm.
Mole per what? dm3. Am I communicating? Are you with me? Any question? Any question? Okay, having known the formulas for solving this, in our next contact, we are going to be looking at calculations, isn't it? Go to find calculations. So when you go home now, what are you going to do? You're going to find questions under what solubility, their calculations, and what start solving. Even theoretical aspect of it, you know, has questions, isn't it? So by the next contact, we are going to be looking at what calculations under solubility. So having done this, having known what solution, solubility, factors affecting solubility, and of course the formulas and the relations for solving or calculating solubility of a substance, we are going to be calling it what? A day, right? So thanks for listening.
Thank you.